Our next example demonstrates the functionality of a set container, which is designed to retain only unique elements. So if we insert non-unique elements, like in this example, only one copy of it will be retained, and set automatically checks whether the value is already stored. So anyways, this is our very quick sample of the set functionality. So the set is parameterized here in this example by an integer type. So this will be a set of integers. It's called iSet. So we insert some values. So insert function places values in the set. And if you want to determine whether the value is already stored, you can use find. So find returns an iterator, right? And this iterator will be set to the end of the container if the value is not found. If the value is found, then you will get an iterator that you can use to access the element. Okay, with this in mind, I would like to show you actually another way of doing this. Let me just perhaps try this part right here. If you only need to find out whether if you only need to find out if the element already exists in a set, instead of find, you can simply use count. So count simply returns 1 if the value is present. Okay, so if you don't need the access to that element, if you want really just to check whether it's stored, you can do it this way. So let's see, like if we, for instance, remove this insert and insert only these values, but check for the presence of 55, then we should be inserting 55. I'm expecting this this if statement to succeed. Actually, if not count, right? So if we say if not count, or we can say if counter returns 0, right? If counter returns 0, then we want to insert this value 55. So let's find out. Again, the same approach. We can use the iterator. So once again, we can use the simplified syntax like auto iterator equals iSet.begin. So this just like with an examples of vector, sets the iterator to the beginning of the container. And then we can use a loop like this for basically for this iterator. Okay, that is still not at the end of the container iSet. So iSet end. So as long as this is not at the end of the container, we want to increment the iterator. And here we can be printing. So I'll just copy the cout statement right here. We can then print the values from the container using this iterator. So we need to dereference the iterator to access the element because the iterator emulates the behavior of pointer, so it supports the dereferencing. And of course here we're using this iterator to advance it forward as we iterate through the content of our container. So here I will be printing these numbers out of this set. So let's take a look. I save it, build. Okay, so there's some errors. And yes, so I just need to say standard set here. Okay. I make this adjustment because I'm not in big favor of using namespace std directives like this, just throwing things into the entire scope of my program. I find it to be much clearer to use a standard library namespace prefix in front of the elements of the standard library. So let's now run it, Control F5, and you can see that yes indeed the element, of course, these elements were inserted, and then we have element 55 also inserted because its count was 0. So just keep this in mind, that you can manipulate a unique set of values. This is really unique integer numbers. There will be no duplicates, like our attempt to store 22 twice did not succeed. It just retained one copy of it.